All right, guys, let's take a look at another type of angle we're going to see. We talked about central angles and arcs and how they're related. Today we're going to look at inscribed angles. So an inscribed angle is an angle with its vertex on the circle. So we talked about these a little bit when we went through the definitions for the beginning of this unit. And the two sides of these angles are going to be made up of chords. Remember, chords are those segments that have both endpoints on the circle. So in this case, we have chord AB on here on the left, and we have chord BC on the bottom here. And vertex B is on the circle, therefore it's an inscribed angle. The intercepted arc, that's another name for the angle or the arc that this inscribed angle opens up to. Okay, so we say it opens up here to this intercepted arc. Okay. So it's made up of those two endpoints of the angle. So we have angle ABC, A and C are the endpoints here. So that's the arc it opens up to. So the measure of this angle is equal to half the measure of its intercepted arc. So whatever the measure of the arc is, it's going to be half of it. That angle down at the bottom, ABC, will be half of that. And which gives us our formula here, the measure of angle ABC, and the M stands for measure. The measure of angle ABC is equal to 1/2 the measure of arc AC. So if the arc is 80 degrees, then the angle is 40 degrees. Now we have a couple of different theorems or properties that go along with this, and that's when you have an intercepted angle, or it intercepts the diameter, okay, the inscribed angle intercepts the diameter, then it's a right angle. So if you'll notice here at this picture here, this is the diameter, and we know it's the diameter because it goes through the center. So that's one thing you need to make sure you look for is, does that line go through the center? Now, this means that this is going to be a right angle, because if this arc right here is 180 degrees, then half of it would be 90. So the measure of BAC is 90. Overlapping arcs. This is when you have two arcs that overlap. Okay, or two inscribed angles that overlap here, and the arcs kind of combine. So if we have two inscribed angles that intercept the same arc, then we say those are congruent because they're both half of the same angle. So we have our inscribed angle here, and we have our inscribed angle here. Notice if you follow these up, it goes to D. Here on this side, it goes up to A. So therefore, this arc right here is one they both are intercepting that arc, which means they're both going to be half of that arc, so they're the same thing. All right, so let's look at some of these and kind of work through and kind of go through how to solve these. So we look here we're looking for the measure of angle WXY. Okay, so if you were to follow this could be with your fingers here. You don't have to draw these. I'm just kind of showing you this is the angle here. The arc that it intercepts is going to be this one, WY, which you'll notice here from the endpoints of this angle. So if this is 62, this is half of it. So that's going to be 31. So 31 degrees is the measure of this angle. So this would be 31 degrees. So you can set up the equation to solve it, but you can also just do the math in your head or on your calculator. So this one, looking for the measure of DH or DGF. So now we're looking for this D, G, and F, this arc all the way across to here. Now what we know is that the inscribed angle is 113. So before we said the angle was half of the arc. Well, if we know the angle, that means this has to be double. So you're going to multiply it by 2 and get 226. So our answer is 226 for this. So if we do the setup here, we have angle DEF is equal to 1/2 of, this is the math behind it, of the measure of arc DGF. Okay, so plug in the numbers we know. This is 113. 1/2 the measure of DGF. To get rid of this 1/2, we're going to multiply by 2. And that cancels the half, leaving us with the measure of DGF equal to 2 times 113, which is going to be 226. So when it's simple like this, you don't have to set up the equation. You can just know when you're doubling, when you're going to be taking half. So look at number 3. Number 3 here, we have an inscribed angle here at Q, and it opens up here to a diameter. If you notice here, this point P and point R going across here, it goes through S, so we know that's a diameter, which means this is 180 degrees over here, which means that this will be a right angle, because half of 180 is 90. So the measure of PQR is going to be 90 degrees. Let's look at the next one. We're looking for the measure of arc BC. So we have to do a little bit more work. Now, one thing we know here is that this is 47, so this angle is going to be double that. So if we double 47, that's going to give us 94. That means from A to C, it's 94. But we're looking for B to C. Now, once again, you need to notice and always be able to identify diameters, because that tells us that this half of the circle is 180. That tells us this entire circle, half of the circle, arc ACB, is going to be 180. So to find our measure of BC, we're going to take 180 and we're going to subtract out the 94. Excuse me. And that's going to give us the 86. So 86 is going to be the measure of arc BC. You can always double check it by adding 86 and 94 to make sure it does equal 180. So now we're looking for the measure of JKL. Okay, so we want to know this arc right here. So we're looking for J, K, and L. We want to know this angle. Okay, whoops, sorry, let's go back there. Looking for JKL, this angle. So we want to know, what is this angle right here? Well, we know this is 65, this is 53 around it. It's going to be half of the arc JML. So to find JML, we're going to take and we're going to add up these other two arcs, because remember, all arcs are going to add up to 360. So we're going to have 360 minus the sum of 65 plus 53. We're going to add those together, which is going to give us 118. And we're going to subtract from 360, which is going to give us 242. Now, that means that this arc out here is 242 degrees, going from J all the way through M and around to L. The angle we're looking for is going to be half of that. So we're going to take half of this. So we're going to take and divide by 2, which is going to give us 121 degrees. So let's look at the next one. Now we're looking for RST, angle RST, and angle RUT. So angle RST is going to be this angle here. So we get RST. So we're looking for this angle right here. And then we're looking for RUT, which means we're looking for, and I'll do a different color here, RUT goes like this. So we're looking for this angle here. Notice both of these open up to the same arc. So if we look here, we've got this arc right here. They're both opening up the same arc, which means if we find this angle, then we know that it's this arc. These are two going to be the same angle. So let's take a look at what we know. We have 64 from RS. Arc SU is 139. TU is 75. So we need to figure out what is RT. Now remember, all arcs are going to add up to 360. So we're going to add them all up and subtract from 360. So 360 minus the sum of 64 plus 139 plus 75. So 360 minus, in this case, is going to give us, let's see, we add these up here. 64 plus 139 plus 75 is going to give us 278. We subtract that from 360, and that's going to give us 82. So 82 is this. That means this arc is 82. Now, these angles are going to be half that, which means we divide 82 by 2 and get 41. So both of these are going to be 41. All right, so let's look down here at the next one. So now we're going to add a little algebra in here. So you can do this a couple ways. You can set up your equation and solve, or you can figure out what the angle is going to be and then set it equal to that. So we know this angle here is going to be and I'll show you both ways. We can say that this angle here is 8x minus 9. It's the inscribed angle is equal to half of the arc it opens up to, which is 158. So if you take half of 158, that's going to give us 79 equal to 8x minus 9. Add 9. 8x is equal to 88. Divide by 8. X is equal to 11. So another way to work this is find out what this measure this angle is. So you could take 158 and divide it by 2 and find out that's 79. So you could say 8x minus 9 is equal to 79, which is basically this step here. It's doing the first step in your head. Either way is fine. It's just whatever makes sense to you. Okay, so our value of x is going to be 11 here. Let's look at the next one. All right, so we're looking for this. We have our inscribed angle, which is 67. So 67 is equal to half of the arc it opens up to. So this is going to be half of arc LN. And since we have the measure of LN, let's go ahead and put that in here. So it's going to be half of 4x plus 58. Now, you can either multiply both sides by 2, or if these both are even numbers, 4x and 58 are both even, so we can distribute this 1/2, which means we're going to multiply it here, and basically you're taking half of each one, so you're dividing it by 2. So this gives me 2x, this gives me 29, equal to 67. So now we're going to subtract 29, and 67 minus 29 is going to give us 38. Divide by 2, and x is equal to 19. All right, let's take a look at the next one. So this one here where it says we're solving for x. If we know that this angle right here is an inscribed angle and it opens up to a diameter, that means this angle is going to be 90. So we can say 13x minus 1 is equal to 90. That's probably the quickest way. But you can also do it as, you can also set it up on the side as 13x minus 1 is equal to half of 180. But you should be able to look at this as one of these that you should be able to look at and know what this angle is. So we're going to add 1. 13x is equal to 91. Divide by 13, and x is then equal to, let's see here, it is going to give us 7. All right, let's look at the next one. We have an inscribed angle of 114. They give us an arc of xw of 78, and we're looking for the angle 7x plus 6. So, first thing we're going to do here is we're going to look at, we need to know what is arc xy. Now, notice that this is not a diameter, so we can't just plug that in here to know what that is, okay? But, so another way to do this is, we know this angle, this is a triangle here. We know the triangle adds up to 180. So one thing we do know is we can find angle y because it's half of 78. So you're going to take half of 78, which is going to be 39. So that's going to be this angle here. And now we need to figure out what this third angle is here, angle xwy. And if we can find that, then we can know that this angle is going to equal that. So I'm going to say 180 minus the sum of 114 plus 39. So we add these two angles up and then subtract from 180. And that result is going to give us, let's see here. Now we can also do it and add these angles up. So if I do 114 plus 39, that's going to give me 153. Subtract 180 from it. So minus 180. That's going to give me 27. So 27 is this angle measure right here. So what we can do is we can just say 27 is equal to 7x plus 6. Subtract 6. 21 is equal to 7x. Divide by 7. X is equal to 3. So that's another way to do that. Okay. You could also have said that 39 plus 114 plus 7x plus 6 is equal to 180 and solve. Let's look at 11. We're looking for x again. So we know this angle here is going to be half of arc AC, so we need to find out what arc AC is. So BC is 162, AB is 92, so all three together are going to equal 360. So we're going to do 360 minus 92 plus 162. That's going to give us a measure of 106. Okay, so that's how we get that measure. Now we can say that our inscribed angle, 7x minus 10, is equal to 1/2 of 106. Half of 106 is going to be 53. We're going to add 10. 7x is equal to 63. Divide by 7. X is equal to 9. All right, so now we're looking for RS. Notice it's not the arc that the intercepted angle opens up to. So we need to figure out what this angle is so we can find out what the measure of RS is. So 67 times 2, that's the first thing we want to do. And let's see, that's going to give us 134. So now we have two angles here. So if we add that to 120, that gives us 254. So 254, and we're going to subtract that from 360. That's going to tell us that that measure is going to be, let's see, 106. So that means that this angle 5x plus 21 is equal to 106. Subtract 21. That's going to give us 85. 5 by 5. X is equal to 17. All right, let's look at 13. So now we're going to have to do a little more work because we got two equations now. So it says the measure of angle FGH, which is this angle here, is equal to, or excuse me, is 6x plus 21, and the measure of arc FJH is equal to 17x minus 28. Find the measure FJH. So our inscribed angle, 6x plus 21, is equal to half of the arc it opens up to, which is 17x minus 28. Now, since 17 is odd and this one's even, 28's even, we don't want to distribute because that gives us a fraction. So one thing we can do is get rid of this. And so the way we get rid of it is going to be by multiplying both sides by 2. That's canceling the half, which gives us now, distribute this, gives me 12x plus 42 equals 17x minus 28. Next thing we want to do is we want to bring the x's together, so I'm going to subtract 12x. I'm going to add 28, bring this to the other side. This will give us 70 is equal to 5x. Write this up here. Divide by 5. And x is equal to 14. So we're not done yet. We have to plug this back in and find the measure of arc FJH, which is the second equation. So we're going to do 17 times 14 minus 28. Oops. And when we do that, we're going to get 238 minus 28, which will give us 210. So 210 degrees is our answer. All right, look at the next one here. The measure of angle STU, which is this angle here, is equal to 5x minus 16. And the measure of SU, which it opens up to, intercepted arc, is going to be 12x minus 50. So 5x minus 16 is equal to half of the arc it opens up to, which is 12x minus 50. Both of these are even, so I can distribute and get 6x minus 25 equal to 5x minus 16. Subtract our x's, or bring our smaller x to the larger x, which means I'm going to bring 25 to the other side. That gives me x here, and this is going to give me 9. So x is equal to 9. So we're looking for angle STU, which is the first, which is the inscribed angle. So we're going to put angle STU is equal to 5 times 9 minus 16. So 45 minus 16, and that's going to give us 29. All right, let's look at 15. So we got more overlapping arcs and angles here. We got angle ABC. So that is going to be this angle right here. And that means it's going to open up to arc AD. So we have also angle ACD. So this is ACD. Notice that this opens up to arc AD. This one opens up to arc AD, which means that these are the same. So that tells us that we can set these equal to each other. So 6x plus 26 is equal to 13x minus 9. Now what we're trying to find is we're trying to look for arc AD, which means that once we find our x, we have to plug it back in and find the angle, and then double it to find our arc. So solve for x. So bring our 6x to the 13, which means I'm going to bring the 9 to the 26. This will be 35 is equal to, so we got 7. Divided by 7, x is equal to 5. So now we go back and plug it into either one of our angles, doesn't matter which one. Let's say we go 6 times 5 plus 26. That's 30 plus 26, which is going to be 56. So if this angle is 56, this angle is also 56. So if we double it, that's going to give us 112. So 112 degrees is our answer. We're just multiplying this by 2. All right, so once again, if you look here, we notice that this angle JKL opens up to a diameter, which means this is a right angle. So angle KJL is equal to 3x minus 2. That's this angle here. And the other angle KLJ is going to be this angle here is equal to 7x minus 32. So if this is a right angle, then these two angles have to equal, angle at J and L are going to have to equal 90 as well. Okay, the sum of those will, because together they have to equal 180. So that what we can do here is we can say that this the measure of angle KJL plus the measure of angle KLJ is equal to 90. So if we add these together here, we're going to get 3x plus 2 plus 7x minus 32 equal to 90. So we have 10x. This is going to give us a negative 30. Add 30. 10x is equal to 120. Divide by 10, and x is equal to 12. So they want to know what is the measure of arc KL, which means we're going to have to know the measure of J here. So we go to this first one, KJL. So if we plug this in, we get 3 times 12 plus 2. Oops, don't need that last parentheses here. That's going to be 36 plus 2 is 38. So if this angle right here is 38, then this angle KL, this arc KL, so KL is going to equal 2 times 38, which will be 76. So KL, arc KL is 76. All right, so remember, inscribed angles means the angle is on the circle, okay? In the next video, we're going to look at inscribed quadrilaterals.